Hi, the Astro 30 here, and today we're going to talk about the law. No, not the popo.
Ohms. It's not just fun, it's the law.
That law. And we're also going to explore the power law, which is slightly related to this, especially if you want to calculate the wattage of a resistor you need for the current that's going through it. Anyway, I digress. When you look up Ohm's law on the internet, you'll often see it represented as this triangle of various different colours. I think it's red, yellow, green or blue. I can't remember offhand. But for the first time looker honor, if that's a word, it is now, this is kind of confusing. But it basically means this down here. V, which is the energy put into the circuit, equals I, which is the current going through the circuit, which is carrying the voltage, multiplied by the resistance of the load, which can also be its impedance, but impedance is not the same as resistance. That's a whole different topic. So never ever confuse impedance being the same as resistance. It is not. So sometimes you may see that V replaced with E for energy, but it basically means the same thing. And the inverses of this, if you want to know the current of a circuit, then that's supposed to be a V divided by R. So you can work out the current via the voltage divided by the resistance. And make sure you get these figures the correct way round, or the values of these the correct way round, because the math may come out different, especially when you start working with 0.0 of amps, like say 50 mA, because it's going to be a decimal point number. And if you have these two reversed around, you may get a different value. You can also work out the resistance of a circuit, not that I would see a need to do that, taking the voltage divided by the current. So those are the inverses. But first, we will talk about the main one, working out the voltage in a circuit via the current divided by the resistance. So we already know that two values. You need to know two values for this calculation to work. We know the current, we know the resistance in this example. The current is 0.1 amps or 100 mA. We can then multiply that by the known resistance of the circuit, which is 100 ohm. So the voltage is in volts, the current is in whole amps or decimal point amps, and the resistance is always in ohms. So if it was 10k, it'd be 10,000 ohm. Keep that in mind. So that will equal 10 volt. So we know that the voltage equals 10 volt. You may be saying to yourself with that, well, how's that important? Well, say we didn't know what the current was, but we know the voltage and the resistance. In this example, take our 100 ohm resistor. That's the common line, so that's negative, that's positive. That's the load that that resistor is connected to. We want to know what the current draw on that circuit is. We can do that simply by putting our multimeter across that resistor and measuring the voltage drop. And in our example, we have 10 volt voltage drop across that resistor. So we now know that the current is going to equal the voltage, which is 10 volt, divided by the resistance, which is 100 ohm, which is going to equal 0.1 amps, or 100 milliamps. Isn't that nice? So how is this useful? Well, you can use this sort of formula if you're adjusting a power amp's bias and you want to set it to about 50 mA. You can work out what the voltage drop across a resistor is to what the current actually is. We're also going to look at the second law now, which is the power law, which is how much wattage is going for a circuit. So P is the power in watts, equals voltage multiplied by the current. Take our example before of that 100 ohm resistor with 100 mA going through it. We want to know what the wattage is of that resistor, so we know that we're not exceeding the wattage of the resistor. So it'll be the voltage, 10, which is our voltage drop, multiplied by the current, which is 100 mA. Again, this is in whole volts, and that's in whole amps. So if we multiply 10 by 0.01, well, that's pretty easy. That's going to equal 1 watt. So for the example of the 10 volt drop going across that 100 ohm resistor in the last section, the resistor's power handling has to be at least 1 watt. That's how much dissipation is going to be across that resistor, 1 watt. So in conclusion, I hope you found this video useful and you use these laws. I use them all the time. And I hope I explained it as best as I could and that you can understand it. Please drop a like, subscribe down below if you haven't already. You can always follow me on Facebook or become a Patreon supporter for as little as $1 a month. All the links are in the description as usual. Anyways, this is the Astro 30 saying happy
Ohms.
I've really got to stop using that clip. It's going to turn into a meme on my own channel.